Okay, a final topic on the law of large numbers is an application of the law of large numbers in what's called Monte Carlo integration. So a lot of times in practice, we might have a random variable that we just really don't know how to, we want to work with it. We want to calculate an expectation, or we want to do some kind of probability calculation for it, but we just don't have, it's just not possible. It's not tractable to do it in a closed form. So when that's the case, what we're left with is we can use simulation and apply the weak law of large numbers to give us an estimate of an integral of interest. So let's suppose, for example, that f is a function. We define it as a function from the unit interval to the real numbers, and such that the integral of f of x cannot be directly computed. Okay, so what do we do? Well, we can consider the following integration technique. This is called Monte Carlo integration. Let's take an IID sequence of uniform 0, 1. And let's define I hat of f as a random variable, which we define as the sample average of this function f evaluated at the random variable. So this is a sum of random variables. And because the UIs are IID, the F UIs are IID. Note that FU1, FU2, FUN, etc. are IID. We don't necessarily know their distribution explicitly. Okay. Then for each I, what we have is that the expectation of f of ui is the integral that we're interested in, right? So it's the function evaluated at u times the density of u, but that's just the constant 1. And also the expectation of our random variable I hat f is just the expectation of any given f of ui, which is also. So what does that mean? Well, that means that if we take ui to be the n's to be large enough, then the weak law of large numbers implies that I hat of f well approximates the integral that we're interested in. So we can just generate uniform random variables on the computer, generate as many as we possibly can, and calculate this quantity here. And that's going to give us, by the weak law of large numbers, a very close and good approximation of the integral of interest. So this is a common technique. It's called Monte Carlo integration. It's something that comes up in a lot of statistical contexts, especially when we don't have a tractable integral. A lot of Bayesian applications rely heavily on this or on more advanced techniques of the same sort, still using this Monte Carlo integration technique. But at the core, really, this idea of the law of large numbers is really critical to these applications. And so this shows how not only is the law of large numbers something that is very important and fundamental in the practice of statistics and probability, but it also comes in applications and computing as well.